Hello students, Professor Nugent here. In this video, we are going to begin our discussion of the other cause of non-stationarity, which is brakes. Another form of brakes is model stability. So what does this mean, brakes? What does model stability mean? Well, this means that the coefficients of the model might not be constant over the full sample. Okay, they might not be constant. So this is a problem for forecasting if the model describing the historical data differs from the current model. As you want the current model for your forecast. It's an issue for external validity. How well can the current model predict out of sample? You want the coefficients to be constant over time. So we're going to go over some ways to detect changes in the coefficients. We're going to test for a break, and we're going to look at pseudo out-of-sample forecast analysis. In this section, we will work through an example predicting gross domestic product using the term spread. We are focusing in this video testing for a break, which is a change in the regression coefficients, in the case that the break date is known. Suppose the break is known to have occurred at date tau. This date may be at any point between t equals 1 and t equals capital T. All right? Suppose that you know that there was a significant change in the economy in 1994 that matters for the series that you're studying. Then, you would set tau equal to 1994. The stability of the coefficients can be tested by estimating a fully interacted regression model. In the case of the autoregressive distributed lag model, with one lag of the y variable and one lag of the x variable, this first line is the ADL, and the second line includes the interactions to test the break date. So the interaction includes this dt of tau, which equals 1, if time is greater than or equals to tau. In our example of 1994, tau equals to 1994, d is going to be, the dummy, d is going to be equal to 1 if time is greater than or equal to, or in other words, equal to or after 1994. So for years 1994, 1995, 1996, the dummy is equal to 1. The dummy will be equal to 0 for all years prior. So we're going to interact the dummy. We'll have a dummy by itself. We interact the dummy with yt minus 1, and we interact the dummy with xt minus 1 to see how those coefficients might be different from the delta 1 and the beta 1. If gamma naught equals gamma 1 equals gamma 2 equals 0, then the coefficients are constant over the full sample. And this test, you should have some intuition telling you, oh, I know how to test that. Folks, that's a big ol' F test. If at least one of the gamma naught, gamma 1, gamma 2 are non-zero, then the regression function changes at date tau, because you know that after 1994, then there is some increment, gamma 1, in addition that adds to the beta 1. All right, so let's continue this discussion. We have specified our fully interacted model with this big old rainbow star here, and our tau test statistic for a break at date tau is the heteroscedasticity robust F statistic that tests the null hypothesis that gamma naught equals gamma 1 equals gamma 2 equals 0 against the alternative that at least one of gamma naught, gamma 1, or gamma 2 are non-zero. We can apply this to a subset of the coefficients, such as only on x or only on y. And unfortunately, we don't often have a candidate break date, so we don't often know tau, which makes this procedure complicated. So if you don't know tau, then what do you do? Stay tuned to the next video when we discuss how to search for a break when you don't have a candidate break date. When you don't know for sure that tau equals 1994, for example. Stay tuned.